Today we will start learning the multiplexer and decoders. Okay.
No.
So basically, multiplexers are like which selects or which choose like between multiple options and give one output. That is multiplexer. Okay. So how it looks like basically, let's say a 2:1 multiplexer we want to design. So how it look like? It looks like Uh, basically, the symbol of the multiplexer in the hardware is like this. Okay, and
Yeah,
this.
I think you're not sharing the screen.
Okay, sorry. Yeah. So symbol of multiplexer look like this, and there is a one output and multiple inputs, and there will be a select line. Okay. So basically, this select line. Let's say this is a 2:1 multiplexer. 2:1 means two input. This is input and the one output. Okay, so this two input and one output, and based on the selection, like this is select. So it chooses either this one or this one. So this selection input is 0 and this selection input is 1. This can be anything, like it's say in 1 and in 2, and this is out. So whenever the selection is 0, 0, it chooses input 1 as output, and when selection is 1, it chooses in 2 as output. Okay. So let's say what looks like internal to the multiplexer.
Okay.
Okay, so let's have a truth table. Now we know like what is doing. So let's have a truth table. In one, in two, and selection is out. So 0, 0, 1, 0, 1, sorry, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, and 1, 1, 1, 1, 0, 1. So what will be output here? When selection is 0, it chooses input 1. Basically, input 1 is 0, it will remain 0. When this is 1, again choose the input 1, input 1, input 2 is 0. When this is 0, it chooses again 0. When this is 1, it chooses this one, 1. When this is 0, it chooses this one, 1. When it's 1, this chooses 0. When this is 0, it chooses, sorry, in 1. When this is 1, it chooses into 1. Okay. Hmm.
Hmm.
This is like, so now let's have a Kmap. So this is in 1, in 2. Okay. This is 0, 0, 0, 1, 1, 1, 1, 0. And this is selection. This is 0 and this is 1. Okay. So when this is 0, the output is 0. When 0, 0, 1, output is again 0. When 0, 0, 1, 0, output is 0. When 0, 1, 1, output is 1. when 1 0 0 output is 1, when 1 0 1 output is 0, when 1 1 is 0 output is 1, and then here also 1. So now we see like, can are we having pairs? Yeah, we are having pairs. This is one pair, this is one pair, this is one pair. Okay. Mm. So what is this? So this is like the common is select, and then here it is uh,
I2.
into. Okay, so this will become into and select. Okay, plus what is this? This is again select is not common, so this will be like in one into. Okay, and this is basically we don't write actually. We are simplifying it. Don't need to simplify it. So basically, this is okay. Let's not make a pair. Okay, pair making is making it. It's like simplified, optimized version. Okay,
Okay.
we don't optimize it. Okay, we make it simplified. Don't simplify it. Let's erase it. Basically, we want to make a structure. Four outputs are there. This output is what? Now, this output is select. Select is one. Okay, and select is one. At that time, what is the input is choosing? Select
Input 1 bar.
input one bar.
I2.
Uh, select input. Yeah, input one. Input one bar.
And the
Input.
input.
I think we have to make a pair. Otherwise, we have to optimize it, right? So let's choose this again. So this is and this is select, and this is sorry, input two. Huh? Yes, and this one is what? Oh, this is already made pair. No need. Okay, sorry. That's what making mistake, right? My third item is coming. That is already done, right? 1 1. Okay. Two pairs. Third pair no need to make. Already everything is paired. And this is like a select bar, and this is a in one. Okay. So this is out. If we try to design it, what is one input? Yes, two AND gates are there, right?
At 2 and
One
gates.
AND gate yeah, yeah. So this is in one, let's say in one, and this is into. Right? What into? And what is other input? So here with into the input is select. Okay.
Yeah.
And what is the input for the this one? This one is
Not.
not of select. Okay. And then or get. So this is basically the whole multiplexer inside this. Okay. So what it contains? It contains this part. If you consider this part is a decoder. This part is a like selection and an OR. So a multiplexer contains a decoder and uh, like and OR structure. Okay.
Okay.
So if you want to design a bigger like mux, let's say 4:2. Okay. So let's say plus and there is bigger mux. So what it will contain? It will contain bigger mux 4:2 in 1, in 2, in 3, in 4, and out. And 2 is select lines, right? S1, S0, because we want to select 4 combination. Okay. So what will be there? There will be a decoder. Okay. And what decoder will generate? It will generate a, there will be a 4 AND gates, right? And then it will be a OR gate. Okay. And then what will be, so each gate will be taking these inputs. Okay. And what will the other input? The 4 output, 2:4 decoder will generate 4 outputs. And that will go here. Other will go here. Other will go here. Other will go. This will be, this is generic any multiplexer architecture or hardware or logic. So what it contains? It contains a decoder and or structure. Basically, it's sum of products. It will contain a decoder and sum of products. Okay. So decoder is like usually what we need to do, we need to decode the select lines and then create a multiplex, create a sum of products using the select line as select outputs from the decoder.
Yeah. Yeah. Makes sense.
Question here until here?
No, no, I don't see any question. So basically, we are using the decoder because these are the AND gates, so it will only activate when decoder output is 1.
Yeah, yeah, yeah.
So, yeah,
That's correct.
so that makes sense. Yeah.
So let's say let's design a 2:4 decoder, a 2:4 decoder. Okay.
Okay.
So what how decoder looks like? Let's do that. S1, S0, and out. So 0, 1, 1, 0, 1, 1. Okay. So when 0, 0 is there, output will be like it will select. Uh, sorry, it's 4 outputs, right? So
Yeah.
out 0, out 1, out 2, and out 3. Okay. So how, what when 0, 0 output will be 1, this one, this will be 0, 0, right?
Zero.
When 0, 1, this will be, when 0, 1, this will be. So you see, like for a decoder, the only one combination will give you one output, right? Rest combination of S0 will give you 0, right?
Yes, yeah,
So so let's say this is a Kmap, right?
yeah.
0 S1. So here it will be 1. Other case it will be 1 here. Other case it will be 1 here, and so on. Okay. So this is like, it means like each combination of S0 and S1 is giving one output, right? So what is how it looks like? It will be like
Yes,
S0, S1 bar. Okay. So all combinations. So each combination is giving one output of
yeah,
select line. Okay.
yeah.
So decoder always look like each output is a combination of a possible combination of inputs, right? Input select lines.
Okay.
This, this, so on, S1, S0. Okay. So simply we can say decoder is a possible combination of each inputs.
Input. Okay.
Okay. So let's write the code. Okay, write the VHDL code for.
Yeah, I have one question here.
Okay.
So when we are using this decoder, right?
Mm-hmm.
So this looks like more like a shift register. I mean, it shift register does the same thing, right? It shifts the value by one. Is
No,
that
it's not
correct?
a shift register. It's not a register, right? It's a logic gate, right?
So can we, I mean, uh, like we are giving the input like 0001 1011. Based on that, it looks like it's shifting the value of one. The value of one in the one first column, right?
Not
Output zero.
shifting the one, right? It's just a okay. It's not a register.
Yeah, I mean, if you see in the this truth table, right? At the top,
Yeah.
it
So
is
it's not a
zero
shift.
one.
Yeah, it's not a shift. It's not a shift. It's just a one combination output. This is independent. Each output is independent of other output.
Okay, so if I consider this output zero, just output zero, it has the what it has. It has the 1000, right? I mean, I mean,
Yeah, yeah,
if
yeah.
you consider the one as the LSB and zero at the MSB, so that
Mm,
is 100 in that case. So if
mm,
I give the input like I am giving the another input 01, in that case I'm getting the output 0100. So it looks
mhm.
like that one at the LSB, right? That one is moving toward the MSB.
No, no,
You know,
no.
the one which was.
See, first of all, you don't think like it's a whole logic. It's just a truth table. Okay, and for a given input, uh, it will give you only one output at
Mm,
one time.
mm.
Okay, and you don't know which what will your for a given time your first input can be 0 0, next input can be 1 1. It's not a sequential. It's just a truth table. It's a representation. It's not an actual sequence of input.
Okay, so that if the
So first
sequential
time maybe you can give you this input, and second time maybe this input in real scenario.
okay, okay, so
Understand?
that is there is no such a sequential thing. It is
Yeah, there is
combined.
no such sequential thing. It is just a representation. It's all part in the truth table. We try to write all possible
Okay.
combinations in a sequential manner, but it's not. It doesn't mean like in real scenario we'll get this in sequential manner.
Mm,
Okay.
okay.
If
Makes
if it if that is the case, we can just choose this, and then we can predict it what will be the next input. It's not, but we cannot predict what will be the next input.
yeah, 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 makes sense. I understood now.
Okay.
Yeah.
So let's write the VHDL code for decoder,
Okay.
and then multiplexer we will write. Okay. Okay, let's start the Vivado. You're recording, right?
Yeah, I'm recording it.
Okay. Let's Create project. You can rename the project name. Multiplexer and then path. Use. So no files to select. You can choose any device. Finish. Just a question, like, are you able to install the Vivado?
No, I tried Vivado, and that Vivado lab also is there. I tried installing, but it's not working. So yesterday I installed this Cortex Prime. That worked actually, but when I'm trying to get the output to waveform, it is giving some license related issue. So
Because Quartus uses the model sim or third party tool.
yeah, I think
But they have
model
their own. So model sim you should install.
it shows model sim related files and folders when I install that.
But yeah, okay, you have to. Okay, there's a setup is there. You have to set up the Quartus.
Do you know
Yes.
that how to? It shows me that license related error. If
Yeah,
if
we can do that. Maybe that.
okay,
But it's
otherwise
better like yeah, if we maybe tomorrow
please.
maybe we can help you to set up the Vivado.
No, I think first I will remove this Linux. I will remove today and I will put back the Windows. I
Okay.
think that should be much more easier to install
Yeah,
Vivado.
yeah. Windows is easier. Yeah.
Yeah, that's something.
Okay. Because Vivado, yeah. I mean, both are similar design, but I mean, at one time maybe we will go for some small hardware, right? So at that time we have to choose like whether we want to go for a VHDL board, Xilinx board, or the Intel board. So
Yeah,
better we stick to one tool. As
yeah.
other tool is just a tool, right? It's like that can be learned later also. Different
Yeah,
tool.
no, it is similar only. It is
Yeah,
not
it's
that.
similar only. Yeah, yeah. So what? That's fine. So let's create a source. Source. Create. So let's write multiplexer. Two is to one. Okay. So what a multiplexer two is to one had? It has two inputs. Remember, one in the industrial logic, two logic. Other input is select. Then out. You cannot choose the. I mean, out. I cannot write because the same name is there. Okay. But on out is keyword.
Okay,
We
like
cannot choose a name which is a keyword. Okay.
okay.
So now so I remember like there's a decoder, right? So sorry, in the yeah,
So we create first decoder.
yeah. So let's not create a decoder. This is just a two is to one, right? So we can
Hmm.
simply, right? Just this equation. So you can just write this equation first. So it is what? Would be equal to in 1 and not of select R and select. Okay. The design, let's create a test bench quickly. So when you want to create a test, always select the simulation source, not the design source. Okay, because we want to simulate it. Design source means like which is real, which is actual design, that we have to select the design source. Okay.
Okay, when we attach the board that time.
Not, yeah, because what will happen if you choose a design source as the test bench also, right? Then when you simulate, when you synthesize it, it will give you error, like because it is not having any ports.
Yeah, yeah.
TB max 2:1. Okay. We have to make component out of this multiplexer. Now we can just, there's only 4 possible combinations there, right? We can write simple test bench. This is begin and in 1. You can create a counter, right? Because simply, I remember, right? We did a count and easier to assign inputs. So signal std logic. The 3 inputs, right? We want to drive 3 inputs, right? So just we can choose a counter of 3 inputs. You remember, like we did like for loop, right? For I equal to 0, sorry, for I in 0 to 7, because possible value is 7, loop and loop. Okay, and now count value count count plus 1. So it will give you error again, because the count is plus is not defined in this library. So you have to add a unsigned dot all library
Yeah.
package basically, unsigned dot all logic underscore unsigned g unsigned dot all is gone. Now since we have to add some delay, right, in the loop, so that it can hold the value for that much time. Wait for
So if we do not add this delay, what happens?
it will be a like a combination loop. So it will get stuck, because it is like in the 0 time it tries to keep adding in 0 time. Simulation will not move.
Okay.
You don't give any delay, right? It will think a 0 delay, no delay. Okay. So no
So
delay. In the loop you keep adding without delay. So simulation will never move forward. It gets stuck in the 0 time only.
yeah, all the parallel, yeah, it will show all the value in the same column.
Yeah, not parallel. Basically, it's a sequential. Still, it's a sequential only, but is like a delay which is like very small,
Hmm.
and then it will never move. You can see cannot see because
Hmm. Okay.
that's why end process. So now, but we have not initialized any value of the counter, so we just can initialize count equal to 0. And you remember 0, we can initialize h. Okay. So now no error.
So the count, it means that is all three are zero. That initially, that's what it means.
Yeah, initially, yeah, and then it adds 1,
Okay.
and it keep doing this. Okay. So now let's run it. Oh, we declare the component, but we have not mapped it, the map instantiation. Okay. So let's have a signals also, right? Then only we can map, right? Okay. And now we map the like currently we are driving count, right? So how we have to map the inputs to each count, right? Input 1 is, you remember, count 3 in the truth table, right? Count 2. You can assign any value, just a driver, right? Into is count 1 and select is, and then we have to map the component also. Multiplex, so we can say DUT, design for under test. And then we have to make port as map each in one.
In Verilog also we have to do like this, like
Yeah,
mapping.
Verilog also we have to, but different types. Like in Verilog we do no, there's no port map name, but we do like a dot. It's like a dot here, and then there's no this equal to less than. It is bracket
Okay.
like this, different type, and this will not be there.
Okay.
Like this map there.
Like a function. Okay.
Sorry. Done. Now you see, as soon as this is done, the hierarchy will change here. You can see the hierarchy like TV's duties multiplexer instantiating. This is called instantiation in terms of hardware, right? It's instantiation. Okay. The duty or multiplexer is instantiated in the TV test bench. Okay. So this is name means in general terms we say instantiation. Yes. Let's run it. Oh, you know what is the problem? I said right, remember I said right, we have to have a delay right after each assignment, then only the value get assigned. You remember?
Yeah.
But after this, we have not given any delay. Okay. So what happened? Like we have not given any delay after this. So this value is not assigned as zero. So though there's no value is assigned to the counter and initially because this not this is scheduled to assign at the delay any delay, but it's not a scheduled. There's no delay after this, and immediately we are keep adding, keep adding, keep adding. So what happened? The value of the scheduled value of the zero is changed to the new value. Okay, and the new value is just the previous count value. Previous count value was no value. So no value plus 1 is also no value, basically x. So we have to add, we add a weight or 1 ns. Basically what it does, like it scheduled this zero value to assign at some where the weight is there. Okay. Now, see values came here. So now we can look the results. So you can see when the select is 0, it's selecting in 0, which is value output 0. When select is 1, again this is 0, output 0. When select is 0, and this again selecting the out in 1, which is 0. When select is 1, it is selecting into, and into is 1. And here select is 0, in 1 is 1. Here select is 1, into is 0, 1. And it to select 0, output is 0. And then here both are 1, 1. So select anyway we know in 1. And here again it's select into is 1. So this is according to our truth table, the output is coming. Okay.
Mm.
So now let's quickly do a maybe modify this only to implement as 4:1. Okay.
Okay.
Now we know 4 inputs are there, right? This I am doing like to have a easier thing to so that you can see how to implement later. Okay. Three
So the
info.
file name also we need to change in that case, or
No
we can.
need to change. I'm just changing it. No need to change. If you don't want to change the name, don't need to change. Okay.
No.
I'm just it was 2:1 mentioned it. That's why I'm changing. Otherwise, the file name can be anything, but recommended is like it should match with the logic name. Naming should be like we can say by seeing the name of the module, we can say what is doing. Okay. That's how we choose the name. Okay. So sorry, out is only one. Select is vector, right? 2-bit vector because 4 inputs are there. Okay, so now we do a decoder design. Okay, uh, before doing the output. Okay, let's comment it as of now.
I'm coming back. Give me 1 minute. Just 1 minute.
Okay.
Okay, sorry, I'm back.
Okay. So I saying like let's quickly create a decoder code. Okay,
Yeah.
add a source. Add source, which is design source. It's not a simulation source. So create file. And decoder. So decoder is having you remember like four outputs and one input, right? Input is what select maybe we can have like this kind of select. Okay, S1, S0, sorry, S0 in std underscore logic. Um, we could choose like as select and 2-bit select, but it's fine. We can to have a simplicity. We just choosing like this. So, and then let's just select 0. Or decoder outputs. We can set D0 decoder output. Okay.
So here also we can just use that vector uh, 3 down to 0.
Or what? Yeah, we can use. No
Mm.
problem. We can different. But to have us like to so how decoder looks like. You remember the equations? Saying like it's a 1-to-1 equation. So each
Com.
combination will give you one out. So D0 will be what? D0 will be S not of S1 and not of S0, right?
Yeah.
Yes. This will be not of S1, then S1. Okay. Then S0 without not. And then here this will be 2. 3. Right? So now we instantiate this decoder. Let's create a TV for decoder, okay, quickly,
Mm.
so that we understand. Source create simulation source, create file. Then we can say TV decoder. And we can copy this and then we define as a signal this. And we copy paste this TV out input, right, and rename it. Okay. So now you know, right? Counter. We will be having only 4 inputs, right? Got 2 select lines, right? Only 4 inputs in the decoder.
Yeah.
Can choose counter 1 down to 0. This will be select S0. 0 here, S1 here. Okay. And then counter, then this will be 3. the library. Then we have to map the component also. So copy this and then map it. Port map, basically instantiation. We remember port map. This one, this two, minus two D0, D1. Now it's done. You can see as soon as we did here. So, but now if you run simulation, the simulation is selecting this as a top module, so it will run this. So we have to make this as a top module so that it can run this. So set as a top TB decoder. I said so TB decoder. But wherever this select is there, right? It will run that. The three lines, okay, three dots. So now we want to run decoder. So I made that set as a top module. I run it. I have to close previous simulation. Close project. Close simulation. Run simulation. You see, like you see, right? Shift kind of thing, right? You are seeing
Yeah.
basically 0 0 this one, 0 1 this one, 1 0 0 1 1 0 1 1. Okay, so it's selecting like this. So now we use this decoder to create 4:1 multiplexer. Okay, so to use this, what we have to do, we have to instantiate this decoder in our design, right? How we remember we did the half adder and full adder created and then instantiate in the 4-bit adder, right? Like that, we have to instantiate this decoder in the multiplexer logic. Okay, so we can take directly this component. We have already created a component, right? We can copy this component from the test bench, and we can use this component inside this multiplexer. Then also we can use this same instantiation will be there. We can copy this instantiation from here, and then we can use this instantiation here. And then we need this local signals in this file. Uh, so we can again copy. We already created signal here. We copy this signal here, and then we can paste here. So not here. Here. Okay. Now we use decoder, and then we created this signal. Now we have to have a and or kind of signal, right? So you remember here we are using select, right?
Yeah.
So this we can remove it. So this select is what? S0, right? Select 0, we can say, right? You remember we said, right? Select we can have a 1 bit also we can define, or separate two signals also we can define.
Yeah.
So instead of now in the top module, we are defining only one select with 2 bits. So we can instantiate like this. Okay. So now we have a decoder value output. So now we can create what out. So this out p, right? Out p will be what? So uh, basically and you remember and or in the here if you go here. So each not here. Here, you see each decoder output is connected to one AND gate and
And
one input and then giving output. Okay. So we can do the same thing. So in one, it will be connected to D0. Okay. Or into E1, R in 3 and D2, R in 4 and D3. Okay. You see no error. So the design is done. First one multiplexer. Now to test it, we quickly go to a TB test bench. You can just name it if you want. 4, 4, 4. Okay. So now multiplexer is 4-bit, right? 4-bit. So component, you know, we changed to, we added 2 more inputs. So 3, 4. And select is 2-bit. Now we add signals also, same way. Select is 2-bit. Now you see how many inputs are there? 4 inputs and 2-bit select, right? 6 inputs are there, right? So so you have to like increase the count of 6 bits so that we can drive each input, right? 5 down to 0. And then we can connect it or inputs. This may be 5, 4, 3, 2, and select will be what? 1 down to 0 because 2-bit select. Then counter will run 6 bits, means like it will run until what? 63. All possible values, right? Yeah, DUT will change.
so that is 63 we mentioned. We are. Can we use that power? Anything like that?
Yeah, we can use. There is a
Okay.
formula, right? 2 to the power. You remember, when we
Yeah.
made generic, we used 2 power
Yeah.
6 minus 1. So 2 power 6 and minus 1. 63, right? This bracket. Okay, so now test bench is also done. Okay, we can run it. So I remember we have chosen the different test bench as a top module, right? So we have to choose different now. This is a top module. It is a top. So you see like the test bench using 4:1 multiplexer and then 4:1 multiplexer instantiating a decoder, right? You can see here. So now we run it. In our previous simulation, we have to close because this is a different simulation, right? Different test bench. Run it. Oh, here counter we have decoder multiplexer to 5 down to 0. 5, 4, 3, 2, 1 down to 0. So object. Let's see count. What is the count value we added? Add Okay, why in one is X? Oh, here you did not change the name. 1, 2, 3, 4. See. You see, the select is 3. So 3 is like it's selecting all zeros are there. Let's say here, what is select value is 2 here. So it what is the 2 value? 1, 2, 3. So second value is this one, 0, 1, 2. Actually, we should name the 2 means third value, right? So
Yeah.
third value is this one in 3. And here third value is 0. Fourth value is 0. Basically 3 means 4 value, 0. And here see in 4 is 1. So and in 3 is 1. Both are 1 here. So for 2 and 3 it's giving 1. Okay. Here you see all 3 values are 1. So for all 3 selections giving output 1. Some place all 4 will be 1 here. So for all selections giving 1 output 1. Okay, so now let's see elaborated design, how it looks like. Yeah, what we intended to do, you see. So we intended to do a decoder, okay, and each input is connected to output of decoder. In one is 0, so and then OR gate, okay. So it has created chain OR because it has selected 2 is to 1 OR gate, but in libraries usually yeah, 2 input OR gates will be there. So it selected one for each one, chained OR basically. So it's ORing this and ORing this output and ORing this output. So basically together and then output. Okay. And let's see what is there in the decoder. So you see, it's a combination of both inputs. So either 1 or 0 is created this, and then combination of this. So this is what this is I0 of AND gate is what this one S1 S1 0, and this is also uh, S0 0. So both bar here, right? This is coming here from the NOT gate, and this is coming from this NOT gate. So both are bar here. Right? So you can easily visualize also like what we are creating, and then we can see the Vivado. Can go back. Okay. So any question until here?
No. So we had this that selection lines. We had this as I mean manually we are putting right S0 S1. So in the vector, if you do that, how that would look like in that case?
Here, you want to say?
Yeah, I think yeah for the decoder only we
Make it
did that.
equal. So we can just choose like select any name. You can choose S, just S only also is fine, and you can make vector.
Only we do not need to change anything in the below code.
We have to change. Definitely name is changed right now.
Yeah.
Now S1 is what? SG S1, right? That
Okay.
that index of that you have to choose right now. This is S0, and similarly others, right? We have to
Which
choose.
are the index to that.
right? Even D also you could have like vector, and then you could make it bracket and
Mm.
select that index.
And if you have
Now since we changed, right?
mm,
So to give you error. So here we go. Here also we change. Put it as here. We can directly map select, right? Reload. You can see schematic here now. See, yes. Now it's like a select,
like vector. Okay.
and internally it's like it's a vector and choosing zeroth bit here and one bit here,
Mm,
right?
yeah. Okay.
So tomorrow, what we can do, we can focus on now. I have shown you the decoder multiplexer using the logic gates, right? How to design it. Tomorrow we can have a like the using the VHDL code, like if else or case statement or with select. Using this, we will design a multiplexer and also decoder and also priority encoder. Okay.
Mm,
These things we will tomorrow see using the VHDL. Like instead of having a Kmap, instead of using the Kmap, we can still design the using the code. These multiplexers, decoders, etc.
okay.
So we will see how we can use the VHDL language to design this.
Okay. Yeah.
Okay.
Okay. All right. Thank you. See you tomorrow then.
See you tomorrow. Bye.